So hello, my name is Justice, and today we are going to talk about multiplexers and their uses. So multiplexers, or simply known as MUX, is a digital switch that has multiple input sources and a single output source. Let's say you have different devices in your home and you want to connect all those devices to one specific device. The required device used in this situation is called a multiplexer. A multiplexer, as shown in the diagram, allows you to connect different kind of devices. Let's say a MP3 player, a laptop, a digital satellite, and a digital cable TV to a surround sound system. For these two multiplexers to work, it has to follow a sequence of instructions which are based on the simple idea of using logic gates. This example here is a 4-in-1 multiplexer which has, let's take this as device 0, device 1, device 2, and device 3. For device 0 to work, it has to get, here is an AND gate. It has to get a 1 1 1 to get a 1 as its output. So for the device 0 to work, the B has to be 1 and A has to be 1. But if you check the connection from B to device 0 and A to device 0, the it goes through a NOT gate before entering device 0. So that means the device has to start with a 0 or a low before it changes to a high for device 0 to work, and that is shown in the diagram here. So you can see in the table that device A and B are all zeros for the output to come out as device 0. So device 0 could be a 1 or a 0 or on or off only when we have device B and device A as low or 0 or off. If device 1 turns out to be on, device 1, if B turns out to be on, which is 1, it goes through the NOT gate, which converts it to an off, which disallows which makes the AND gates produce an output of 0. The same goes for device A or input A. Let's go to device 1. Device 1 has a different setup. For device 1, we could see that A is connected directly to the AND gate for device 1, but B is connected via the NOT gate to the AND gate for device 1. So we have to get an input of 1 for A and an input of 0 for B before we have device 1 getting an output of the direct device 1. For device 2, the input of B is directly connected to the AND gate for device 2, and the input of A is connected through a NOT gate to the AND gate of device 2. So we would need the B to be 1 and the A to be 0 before the output will come out as D2. That goes, the last one, which is the device 3, is connected to the A and B is connected directly to the AND gate of the device 3, which means it could the input of device 3 will still work if the input of A and B are 1 and 1. So that's basically what the multiplexer is about, and I hope to see you in the next video.